everyone, George here, and we are back again with my animatronic game. I lost a ton of footage in the last video because I was plugging things in and out trying to update the drivers for my Vive. And in doing so, it completely screwed up all of my recording software, which for some reason auto changes when you change the inputs to stuff. So given that, we're kind of back. That is, we might be several steps ahead of where I left off, probably about 30 minutes where I left off. But I found out that the cause of my issue, which was that the buttons were not working properly, was indeed due to an update issue, where the controllers had not yet been updated to the latest version, and therefore when I was pressing the buttons, the wrong things were being read and misinterpreted by Unity. So now, if we come over here, I turn on my controllers. Here's controller 1, here's controller 2, and now if we hit run, we clear this out, and I press the triggers. What you'll notice is that I actually do get proper responses showing up. Now, just on the right one at the moment, because the left one is we haven't programmed that in yet. However, let's see what happens if I stick this on my face now. So here we go. Here we are. There's the left one. Here is the right one. And I can now grab an object and let it go. Everything works. It's just, now that's interesting. So I'm not imparting any physics of my throw. So that might be something I want to consider adding into the game. But anyway, I can pick up the different pieces. Can I grab these feet? That's the question. I don't know where that foot disappeared. Oh, there it is. We can see the pivot's way off. I'll have to consider something there. Where is it going? There we are. All right. So one big issue already is that, let me take this off. One big issue is the fact that I don't know where I'm putting these pieces. So we should probably create something that indicates to the user that, hey, there's a missing piece here. This is where you place that piece, or at least this is where a piece needs to go. I'm thinking maybe we do this via a shader of some sort and use the model that needs to be there, duplicated at that location, and, you know, put like some sort of an outline on top of it. So why don't we go ahead and do something like that? So let's see here. Do we have a shaders folder? No, we don't. So let's go ahead and create a new folder, shaders. And inside of here, let's do, I guess we'll call it animatronic outline. Create shader, standard surface shader. Yeah, sure. And we'll do this animatronic part outline. Now this is going to be a simple shader. We're not really going to do any research for this one. All I'm going to do is probably some sort of a dot product, and the pixel just won't show up if there's nothing there, or the transparency will be set to 100%, whatever you want to. So anyway, shader custom, let's just change that to Glee Cakes so that we have our own separate thing, separate from everything else. Animatronic part outline. We're not going to need metallic or glossiness for this. And we're probably not going to need a texture either. We're just going to go with a main color for the moment. Let's get this out of the way. So render type is opaque. That's probably going to be wrong. That'll probably get set to transparent. Surface, so we're going to be using a surface type, function named surface. It's going to be using standard lighting. Do we need standard lighting? I don't think we do. We can probably just get away with Lambert. This is fine. We don't use a texture anymore, so sampler 2D can go. We do need at least one input, otherwise the input structure won't work. We can get rid of glossiness and metallic. Let's get rid of those. I'm just going to, I mean, this stuff we don't need to worry about. Void surf, input in and out, surf, output standard. So let's, I can never remember these by, you know, just on the top of my head. So let's look up Unity, Lambert, input. And see, so here's surface output standard, surface output standard. I believe I want just surface output. I believe this is it. So what I need to do is make sure I have a value for albedo and for fixed alpha, because that's what I'm going to have. So that's my input, and my in-out is a surface output standard. My lighting model is set to, let's see, what are the lighting models I can use? Not Lambert. Yeah, I can use Lambert. We'll just use Lambert. We can use a standard lighting model or the standard specular lighting model. Let's do decal and see if that works for us. So decal colon add, and this should be transparent as our tag. So in here, we're going to get rid of metallic and glossiness. So here's our albedo color, which comes from a texture which we're no longer referencing. Therefore, it's just the color value that becomes our albedo. And the color is a what? An RGB value. So let's do .RGB. Let's get rid of this. We still have color, right? Yeah, it's right there. Fixed 4. Now, in order to figure out whether or not how transparent this particular component should be, we need to do some testing. So let's do float transparency is going to be equal to the dot product. Now we need to know our forward vector and we need to know the normal of the surface. And both of them, I believe, come from our input structure. So coming back over here to our documentation, so here we go. We have the view direction, which we're going to need. So let's add float 3 view direction. And we're also going to need to know the normal of the surface. So world normal right there. Let's do float 3 world normal. Okay, so with that, we should be able to compare the direction with the normal of that particular location. So let's do that. So dot the view direction and the world normal, but they're both coming from the input structure. So we need to put dot in there, dot in there. And that gives us a value for transparency, which is the dot product of these two values. This, though, is the exact opposite of what we're going to want. This is going to give us a value of 1 when it's straight on and a value of 0 when it's off to the sides or behind it. What we're actually going to want is 1 to clamp this to a range. So I believe, what is it, CG saturate does that? Computer graphics, NVIDIA, saturate. Return smallest integer not less than a scalar or each vector component. Return 0 if less than 0, returns 1 if greater than 1. Okay, that's good. So let's use saturate. I'm going to do saturate on top of this, and we just pass in the value. So now we got a value between 0 and 1, which is the dot product of our input vector and our world normal. And hopefully those are both normalized. So the dot product is giving us a value between -1 and +1 anyway. And with that, we get a transparency value. Depending upon how I want this effect to look, well, for right now, let's just do this. Output.alpha is equal to transparency. And instead of decal, let's just do alpha, what is it, fade? I have to look at the documentation again. Let's come back over here and look at our alpha blend. Let's do fade for right now. Let's save this, go over to Unity and see our errors. So it's saying that it expected a surface output standard, expected one of the sampler 1D, 2D, 3D. Let's double click that. So that's coming in here. So this is probably the problem, surface output standard. I'm not using the standard model. I'm using the Lambertian, or whatever, however you want to say it. So this should not be surface output standard. This should just be surface output, if I remember right. And that disappeared. Good. All right, so now how are we going to do this? Let's just create a new material really quick for this. Material, animatronic part outline, and standard Glee Cakes, animatronic color. Let's do something like, why don't we just do black? Save that real quick. So what I'm going to want to do here is use this material and at the site of each point, create the model and place it at that location. You know what I'm noticing is that the center point of that foot is in the wrong place, isn't it? Because if that's going to get placed, where is the snap point? See, there's the left snap point and there's the right snap point. And that left foot and right foot have pivot points in their centers, which means they're not going to show up in the right spot, which means we're going to have to make the change in Maya, which means going all the way back to the beginning and reattaching all this nonsense once again. which kind of stinks. And I don't want that to prevent me from moving forward. So why don't we just do, I'm going to do a quick test here. I'm going to grab a foot, duplicate it, move it off to the side, and let's give it this material. Let's turn off shaded wireframe, just shaded. All right, so the foot disappears. Well, that's interesting. So is that a transparency issue? So we can see what it's trying to do. Notice that, check that out. So it's definitely not doing what I wanted to do on a shader level. So let's go back to the shader and think about this for a second. I'm also going to jump into my own lecture notes and make sure I'm not missing something, because I probably am. All right, here's the problem. I forgot to do Q. So let's do that. So jumping over here, we have tags, render type, and then we also need Q is equal to transparency. And then we're also going to need to do an ignore projector, and that needs to be true as well. We should also add a cull back statement so that we don't have to deal with the back side of anything. And then instead of decal, let's continue to use alpha fade for right now. And let's come back to Unity, see if there are any errors. There are. It says transparency is an issue. Transparency. Oh, I'm sorry. Transparent. There we are. Let's clear that out. Let's jump back over here, make a small change, come back into Unity, and see if any errors happen. No. All right. And now we fixed the issues with it kind of showing up awkward and weird. But there's still way too much going on. We don't want that much information. We just want more or less the outline of this thing. Let's just do an if statement really quick. If, can I do a clamp? Let me look that up really fast. So CG, can I clamp the range? So I think what we want to use is the step function instead. So we'll saturate and then we'll step. And the way this function seems to work is scalar or vector reference value and then the scalar or the vector. And we're using a single value, a float. And let's do 0.9. So only the angles that are furthest away from us are going to be used for this. And that looks like junk. Let's try something else. 0.7. Now this is a hard-edged object, so that's probably why we're going to get crap. Well, it does kind of look cool. What if I do this? All right, let's make some changes here and see if we can't make this a little bit better. So here we're getting the dot product. And that was producing this effect. So this is going to return us a value between -1 and +1. Let's try the absolute value instead. I wonder if that's going to do anything more interesting. No changes there, and that's probably because I'm culling the back. Now the centers are still going to be more prominent than the outside, so let's do 1.0 minus that to flip-flop things. There we go. That's much closer to what I want. Now we've got the outside's more visible and the inside's less visible. Let's try our step function now. So step 0.9, and then that value is the second part of the function. Okay, we're getting very spindly things. Not quite what I want. Let's try this again. Let's do 7. Still I mean, it's very cartoonish. I almost feel like we should do this calculation twice. Transparency 1, transparency 2 down here. And this one gets done without the step function, but gets multiplied by like 0.1 to make it very light. Like that. And then this becomes transparency 2, which is the step function. And then the final transparency is going to be equal to this one plus, whoops, that one. There we are. And see, now we get a nice light glow and sort of a transparency going on. It's not perfect. I'm definitely going to have to go back in there and revise it, but it's something. And, you know, I mean, the color is 100% black, which is probably not the best color to work with in this case. And in fact, it might be better for me to take this value after it's been processed and just dial that down by like half. There we go. I'm liking that a little bit better. Still pops in and out a bit, but that's also because we're dealing with a hard edge surface. But at least it's something that we can see, a ghosted kind of area for that object and where it should actually be placed. If I select this object, we go to this. Let's play around with the colors a little bit here. Oh yeah, we could definitely make something work here. All right, so let's do a few more changes. Instead of that, let's do 2.5 and let's do 2.5 here as well. All right, I'm liking that a little bit better. Let's increase this a little bit more. 5, leave that as it is. There we go. That's better. Highlights the edges a little bit, but the popping becomes a lot less notable. Yeah, all right. I think that's the shader we're going to end up using for this to indicate where things are supposed to go. Color may change. Who knows? I mean, green might not be the best. Green kind of screams holographic. Who knows? Maybe red would be better. No, not in this case. Yellow. That's funny. Anyway, that's all for this video because I don't really want to jump into Maya again and have to redistribute the placement of these objects' pivot points. I'm going to end this now and have to deal with that sometime later, probably today. Anyway, I'll see you all next time. So long, have a great night, day, evening, whatever it happens to be. Goodbye.